Hello, fabulous calculus students. So today we're looking at assignment 52. And 52 is all about the derivative of inverse trig functions. All right, so let's say, hey, here's an inverse trig function, and I'd like to take the derivative of it. This is not raised to the negative 1 power. This is not raised to the negative 1 power. Do not use the power rule and bring the negative 1 down and subtract 1 here. This is not to the negative 1 power. This is instead the inverse. And I know that if I take the sine of both sides, then sine and sine inverse cancel, and I get x equals sine y. Now, luckily, we know how to take the derivative of sine. And with respect to y, that's implicit differentiation, and we know how to take the derivative of x. So the derivative of sine is cosine y. Don't forget to take the derivative of that inside y, derivative of the inside with respect to x. On this side, the derivative is just 1. So I end up then with dy dx equals 1 over cosine y. And yes, you could turn this into secant y. But here's a problem. That's a y. I don't really want my inverse trig function to be in terms of y. So let's take a look at a triangle and at the statement inverse sine of x equals y over 1. So remember that when we're thinking about this, we're thinking about this is the angle, and there, that's the what I wanted. And sine is opposite over hypotenuse. So I'm thinking about a triangle, and the angle is y. We can maybe see that a little better if we take the sine of both sides. We'll end up with x over 1 equals sine y. So the sine of y is going to be x over 1. All right, use the Pythagorean theorem now to find this missing side. Square root of 1 minus x squared. So now we want to say, what's the secant of y? Well, the secant of y is hypotenuse over adjacent. So secant y can be rewritten as 1 over the square root of 1 minus x squared. So what did we just get? Well, we know if the function is y equals sine inverse of x, we know that y prime is going to be 1 over square root 1 minus x squared. No kidding. That's the derivative of that. Okay. So, oh, and one other thing. Don't forget about chain rule. It's very important in these problems. So if I have y equals sine inverse of 3x, then y prime is going to be 1 over square root of 1 minus this stuff squared. Hey, chain rule, don't forget to come back and take the derivative of that inside function. So I'm going to have here 3 over square root of 1 minus 9x squared. All right? Please don't take the square root of each piece and turn this into 3 over 1 minus 3x, because that's just so terribly, terribly bad. All right. Chain rule. Notice I had to put that 3x in here too. All right, so what about tangent inverse? Oh, you know, before we do tangent inverse, why don't you do inverse cosine? Y equals cosine inverse of x. Okay? Use that same method that I showed that involved solving this for cosine y, and then taking the derivative of both sides. And then don't forget to draw that triangle. Okay. Pause the video, come back when you're ready. Hi, welcome back. So we've got cosine of y equals cosine of cosine inverse of x. These cancel. I have x equals cosine y. Now I want to take the derivative. Well, the derivative of x is 1. The derivative of cosine of y is negative sine y. Okay? So, where do I want to go from here? I want to not forget the dy dx. Remember, if you take the derivative of that inside y, derivative of y with respect to x. And now I want to solve this for dy dx. dy dx equals negative 1 over sine y, or negative cosecant y. This is kind of similar to the last one we did, inverse sine. And it was at this point that we drew a triangle. So we're still talking about the angle y, sine of an angle, angle y. And what do we know? Well, we know here, we know here that the cosine of y is x over 1. So cosine is adjacent over hypotenuse. I get x, I get 1. And then I use the Pythagorean theorem to find this missing side, and I get 1 minus x squared. Okay? Now, what's the cosecant of y? Well, remember, cosecant is hypotenuse over opposite. See that? Don't lose that. That's kind of important here. So then we could say that y prime equals negative 1 over hypotenuse over opposite. And so that's the derivative of inverse cosine. And again, you know, if we had some variation on this, like y equals inverse cosine of x squared, why don't you try that one? Hey, welcome back. So, you know, I'm gonna take the cosine of both sides. Cosine y equals x squared. And now what? Well, I take the derivative of this. I get negative sine y. I take the derivative over here, and I get 2. Oh, I did it again. Don't forget the dy dx. And on the other side, we have 2x. Again, we're going to solve this for dy dx. So I'm going to have dy dx equals 2x over negative sine y. Now, what can we say about sine of y? Well, let's get that triangle going. We know that the cosine of y equals x squared, or x squared over 1. So here's y, adjacent, hypotenuse, and we use the Pythagorean theorem to find the missing side, and we get square root of 1 minus x squared. No, x to the 4th. You know, it could actually be worth your while to do, because then you see that 1 minus x to the 4th equals question mark squared. And then we take the square root of both sides. So that's how I get that. All right, now, what are we looking for? Well, this is going to be 2x, negative 2x, cosecant y. So cosecant y is this over this, right? Hypotenuse over opposite. So negative 2x times 1 over square root 1 minus x to the 4th. Yeah, there it is. That's going to be the derivative of this one. Now, think about it for a second. We know that the derivative of inverse cosine is 1 over 1 minus that thing squared. But because we now have this thing in here, we're using chain rule, and the derivative of x squared is that 2x part. Hey, negative. I wonder what's up with that. Inverse sign was positive. Okay, next inverse trig function. Y equals tangent inverse of x. And I want to take the derivative of this. Okay, so I take the tangent of both sides, and I get tan y equals tangent of tangent inverse cancels, and I get x. All right, so I could draw my triangle now. Tangent is opposite over adjacent, and the angle is y. I want to use my Pythagorean theorem to find this missing side. So I know that's going to be the square root of 1 plus x squared. Great. So the derivative here, derivative of tangent, is secant squared y. Don't forget the derivative of the inside, y, with respect to x. And over here, the derivative is 1. Okay? So now I'm going to divide both sides by secant y. dy dx equals 1 over secant squared y. Secant squared. And that's the same as cosine squared y. What's the cosine of y? Well, cosine is adjacent over hypotenuse. I feel like something's terribly wrong here. But let's keep going. So that's going to be 1 over square root 1 plus x squared. Okay? And then that's cosine of y. How do I get cosine squared? Well, to get cosine squared, I need to do that, and I apply that squaring to both of these. 1 squared is 1, and square root and squaring will undo each other. So that's my derivative of inverse tangent. Again, I don't particularly need you to memorize these derivations. I want you to see where they're coming from, because I think that's kind of cool. But I also maybe give you this method of deriving just in case, you actually take the test without actually reviewing. And so maybe you wanted something where you suddenly said, oh my goodness, I need to figure this out. And I showed you a method whereby you could figure it out. All right, so let's recap. Y equals sine inverse of x. Then y prime was 1 over square root of 1 minus x squared. And we said when y equals cosine inverse of y, that y prime was going to be negative 1 over square root of 1 minus x squared. When we had y equals tangent inverse of x, there we go. We said that y prime was going to be 1 over x squared plus 1. Will you tell me what the derivative of cotangent inverse is? All right, pause the video, give it a try. Hey, welcome back, everyone. So we want to see if we can find the, all right, cotangent y equals x. I draw that triangle. X over 1. Cotangent is adjacent over opposite. So this is x, this is 1, square root of x squared plus 1. All right, let's do derivatives. The derivative of cotangent is minus cosecant squared. Don't forget the derivative of the inside thing. And over here, the derivative is 1. Nice. And so now we've got dy dx equals 1 over cosecant squared y. Now I didn't forget the minus, I just want to put it there. And then when I look over here and say, what's the cosecant of y? Cosecant is hypotenuse over opposite. So I'm going to have negative 1 over square root x squared plus 1. But remember, this is cosecant, but I need cosecant squared. So I have to square this. Okay? And so square root and squaring will undo each other. And so I get dy dx equals -1 over square root. Oop, no, we got rid of the square root. Over x squared plus 1. Okay? That's the derivative of y equals cotangent inverse x. Any relationship to the inverse tangent derivative? Okay. Let's see what's next. We've got inverse secant. Y equals secant inverse of x. Okay, take the secant to both sides. Secant y equals x. So this is the one I want to draw the triangle with. I know secant is hypotenuse over adjacent. And the angle is y. I used the Pythagorean theorem to get this missing side. Okay, so now let's take the derivative here. The derivative of secant is secant y, tangent y. Don't forget the derivative of the inside y, and over here we get 1. So then dy dx is going to be 1 over secant y times tangent y. So 1 over secant, that's cosine y, and 1 over tangent is cotangent y. Now let's use the picture to say what cosine of y is. Cosine is adjacent over hypotenuse, and cotangent is adjacent over opposite. All right, well that's pretty close. Pretty close, but not quite there yet. There's actually just a little bit more to talk about here. So, I know you're wondering what I'm waiting for. Well, so what we just saw was 1 over x square root x squared minus 1. Except there's a problem, because this thing in that last picture, that x that this is, can the hypotenuse ever be negative? No, this can never be negative. And because of that, we need that. And I can't tell you how many people blow derivatives with these because they leave that off, okay? So be mindful of that. All right, so I actually want to come back to this problem and see if we can understand it a slightly different way. Remember how we had secant y equals x, and then we took the derivative and got secant y, tangent y, dy dx equals 1. Okay, now instead of going over here and drawing the triangle, I actually want to pull out a Pythagorean identity. Do you remember this one? Tangent squared y plus 1 equals secant squared y. So what I'd like to do here is solve this equation for tangent. So I know tangent squared y will be secant squared y minus 1. And then I take the square root of both sides. So tangent y equals plus or minus square root secant squared y minus 1. Okay, right? I took the square root of both sides, so I have to remember the plus or minus. Fabulous. Now what? Well, remember this derivative and how dy dx was equal to 1 over secant y times tangent y? Well, I now know what tangent y is. So this is going to be 1 over secant y times plus or minus square root secant squared y minus 1. Fabulous. Now what? What does that mean? Well, when I look at, no, that's not what I want. When I look at, hold on, I need the last step of this proof. There's my y, 1, and square root of x squared minus 1. Okay, so we've got 1 over secant y. Secant of y is this over this, so that's just going to be the x. 1 over x, and then there's this plus minus. And then what about this? So the secant of y is x. Secant squared is x squared minus 1. Undo that square root. X squared minus 1. Undo that square root. Cool. Almost there. Plus or minus. This thing here is always going to be positive. I'm looking for the words. Do you have the words that makes this? Oh, I remember what it is. The hypotenuse is x. The hypotenuse is always positive. So I'm not worried about this. I'm just doing this and saying this thing has to be positive. Ooh. Luckily, you're not going to derive these. You're going to memorize them. So again, sine inverse x, then y prime equals 1 over square root of 1 minus x squared. Y equals cosine inverse of x. We saw that y prime was equal to negative 1 over square root of 1 minus x squared. Then we looked at y equals tangent inverse of x, and we found that that derivative would be secant squared. Oh, it wouldn't. That's tangent. I need inverse tangent. 1 over x squared plus 1. And then we went on to y equals cotangent inverse x, and we saw that y prime there would be negative 1 over x squared plus 1. And then we finally did y equals secant inverse of x, and so y prime in that case was that very interesting. Y prime was that very interesting 1 over absolute x square root x squared minus 1. Please note these. They're not the same. I'm dyslexic. I used to confuse those all the time. Many of my students are not dyslexic, and they still confuse these all the time. So, inverse secant, the x's here are close together, and we don't have an x outside here, so this one's far away. So will you tell me then what you expect the derivative of y equals cosecant inverse of x to be? Based on what you see here, not deriving it, don't take the derivative, don't take the inverse cosecant, don't draw a triangle, just tell me what you think that's going to be. Did you say y equals negative 1 over absolute x square root x squared minus 1? If you did, that'd be perfect. Now, do you notice something here? Co. All the inverse cofunctions are the same as their cofunctions derivative with the addition of that negative, right? X squared plus 1, and that we've got absolute x, square root x squared minus 1, except that this has a minus, all right? Okay, you really need to memorize those. I will tell you that memorizing these, memorizing the log and exponential ones, it's very, very important. That's usually where students make most of their mistakes. Okay, so will you find the derivative of this? Y equals cosine inverse of x squared. Okay? Remember, the derivative here will be y prime equals the derivative of inverse cosine, negative 1 square root of 1 minus this thing, whatever that thing is, squared, times the derivative of this thing with respect to x. All right, that's that chain rule. That's taking the derivative of the inside. So let's apply that here. You should get y prime equals negative 1 square root of 1 minus this stuff squared. Many people, including myself, have occasionally left that squaring off, times du dx, times the derivative of the inside thing, times the derivative of this. And so I end up with a 2x here. You are welcome to stop here, but if your need for tidying is powerful and strong, then you probably want to end up here. And don't box your answers. All right, so there's one. Let's see if we can do some more. I'd like to get to the place where you're really comfortable with these. Cosine inverse of 1 over x. Please find y prime. Find y prime if y equals inverse cosine of 1 over x. Okay, welcome back. Did you get y prime equals negative 1 over square root 1 minus stuff squared times the derivative of that inside function? Remember, we're looking at x to the negative 1 here, so the derivative of this is going to be negative 1x to the minus 2. And what happens if we tidy this up? Well, negative times negative, going to be a positive 1, x squared on the bottom, square root of, well, I know this is 1 over 1 minus x squared, but really don't like a fraction that has a fraction inside of it. So let's make a common denominator here. And so we're going to have 1 over x squared square root x squared minus 1 over x squared. Yeah? See where I'm going with this? So what are we going to have then? Well, I've got 1 over x squared. And then here, this thing, I'm going to split it up into x squared minus 1 all over, square root of x squared. Now remember, the square root of x squared is x. However, remember, both from pre-cal and from August in calculus, the square root of x squared is not x. It's absolute x. So what do I have? I have 1 over x squared square root x squared minus 1 over absolute x. And yes, you're welcome to cancel these. However, x squared is always going to be positive. This is always going to be positive. So when we cancel, we have to make sure that this thing is always going to be positive. And so I write absolute x square root of x squared minus 1. Huh, isn't that someone else's derivative that we know? Yes, this is the derivative of inverse secant. So I know that this expression is identical to secant inverse of x. Okay. I would be surprised if you saw that on a test. Maybe if this were honors AP Calc, we'd do that. But yeah, I wouldn't expect it on our test. Y equals 5 tangent inverse of 3x. Okay, find that derivative, pause the video, come back when you're done. So y prime is going to be that constant times the derivative of inverse tangent, which is 1 over 1 plus stuff squared times the derivative of stuff. And actually, because those are being multiplied together, I'm going to go with 15 over 1 plus 9x squared. Can't tell you how many students write 3x squared here. Don't forget to square the 3 and the x. Any questions about that? Don't forget to use GroupMe if you have questions while watching the video. Can you then tell me what the derivative of cotangent inverse of square root of x would be? Pause the video, give it a try, come back when you're done. Hi, welcome back. Did you get that y prime was equal to, it's a negative 1 over 1 plus stuff squared times the derivative of stuff? Well, this is x to the 1/2, so the derivative is going to be that. Okay? I mean, you can certainly tidy that up. If this were multiple choice, I would need to be tidying this up. But no, I don't need to tidy this up right now for us. How about y equals sine inverse of x over 2? Okay, y prime then, derivative of inverse sine is 1 over square root of 1 minus stuff squared times the derivative of stuff. The derivative of, remember that x over 2 is really just 1/2 x. Please don't use the quotient rule here. So many students do. It's just a constant times x. So my derivative is just going to be that constant times the derivative of this. All right, and for tidiness, I'm going to do something here. 2 minus x squared over 4. 4, so that's going to be 4. And 1 over 2 square root 4 minus x squared over square root of 4. Square root of 4 is 2. 2 and 2 cancel, and so there's my answer. I would accept this on free response, but this is what you're going to see on multiple choice. All right, what's next? How about y equals secant inverse of 5x? Pause the video, give that one a try. Welcome back. Y prime 1 over absolute 5x times square root of stuff squared minus 1. What are we missing? Don't forget to come back and take the derivative of the inside function. And this 5 will cancel this 5, and I'll end up with 1 over absolute x square root 25x squared minus 1. Please memorize your derivatives. Second semester is so much harder if you haven't memorized all the derivatives. And there's no forgetting them a week from now. You really need to own these. Make some flashcards. Practice them a couple times every day while you're flossing. You'll keep it. But if you just ignore it after today, dude, you're going to make your life so horrible. Just practice these things. All right, how about this one? Y equals cotangent inverse of square root of x minus 1. Hey, remember y prime is going to be negative 1 over, because it's a cofunction. Now, what's the derivative of inverse cotangent? Negative 1 over stuff squared. So square root of x minus 1 squared plus 1. And so many people feel like they're done at this point. Except you still need to take the derivative of the inside function. So remember, this is x minus 1 to the 1/2 power. So the derivative will be this. And then don't forget to take the derivative of the inside, but that's only 1. All right. I wonder what happens if we tidy this up a little more. I've got my negative 1 on top. I've got this 2 on the bottom. I have this square root of x minus 1. And I have here, isn't that interesting? What do I have here? I have x minus 1 plus 1. So those cancel. And then I'm left with 2x. Okey-doke. Now comes the real thinky thing. Y equals sine inverse 3x over x. Hey, what you got to do here? You know, I didn't hear all of you say quotient rule. This is a quotient rule problem. I mean, I guess you could flip this up and make it x to the negative 1 and do product rule. I'm going to do quotient rule. So y prime is low d high. The derivative of this is 1 over square root 1 minus stuff squared times the derivative of that inside function, times the derivative of stuff. Are we done? Not at all. It's quotient rule. So we did low d high minus high d low. The derivative of this is 1 all over low squared. No, I do not expect you to clean that up. I mean, you could get rid of that, and you could put these two things on top here, but don't try and go any further than that. It's really not worth it. I just wanted you to know that, look, knowing these is one thing, but being able to do them in the context of quotient rule and product rule, that's going to be something that's going to happen to us. So I wonder about this one. How about if y equals the sine of cosine inverse of x? Okay. No, these don't cancel out. But it is a chain rule problem. So y prime then is going to be what? The derivative of sine, cosine, leave the inside stuff alone, times the derivative of the next inner function. The derivative of inverse cosine is negative 1 over square root of 1 minus stuff squared times the derivative of stuff. So there's my answer. How does this change if I put a 4x here? Please show me what the derivative of sine of inverse cosine of 4x would be. Okay, welcome back. I like to think that you left that alone because you were just taking the derivative of sine. But now when you come back to take the derivative of inverse cosine, you still have the negative 1 on top. You still have the square root. You have 1 minus stuff squared. Well, our stuff is now 4x, so this is going to be 16x squared, times, that's right, the derivative of the innermost function, 4. Okay? One more. Y equals tangent inverse x plus x over 1 plus x squared. Please find y prime. All right, welcome back. The derivative of inverse tangent is 1 over x squared plus 1. And the derivative of this, wow, how do I do the derivative of this? That's right, quotient rule. Low d high minus I. The derivative of this is just 2x all over low squared. Kind of feel like tidying this, but I don't think I'm done. Minus 2x squared plus 1x squared is minus x squared. We've got 1 minus x squared on top. And then on the bottom, we have this thing, and no, I'm not going to bother to FOIL it. Okay. Wow. Well, that's good. I think that's fabulous. So not only should you know all your derivatives of inverse trig functions, like y equals sine inverse of x, then y prime equals 1 over square root 1 minus x squared, and y equals cosine inverse of x becomes y prime equals negative 1 over square root of 1 minus x squared. And y equals tangent inverse of x, then y prime is going to be 1 over x squared plus 1. And if y equals cotangent inverse of x, then y prime is, don't forget it's a cofunction, negative 1 over x squared plus 1. Then we've got y equals secant inverse of x. I feel much better with these being in parentheses. Then y prime equals 1 over absolute x square root x squared minus 1. And so y equals cosecant inverse x. Y prime in that case is negative 1 over absolute x square root x squared minus 1. Please memorize these. And remember that if you have something like 5x here, that 5x is the thing that's getting squared. And you need to come back and take the derivative of the inside function. Please, please, please make a special note about that. All right? Okay, well, I hope this was useful and helpful, and I look forward to seeing you in our next video, which is, by the way, all about derivatives of logs and exponentials, and logarithmic differentiation. See you there.